Okay, welcome everybody. It's 5:30 my time, which should be 9:30 PDT, I'm pretty sure. Thank you all for joining this first Nomad Virtual Day. Hopefully many more to come. So we're going to be starting off with a customer journey by Roblox. So I'd like to welcome Rob Cameron, the Technical Director of Infrastructure of Roblox, to tell about their story with Nomad. And I'm super excited to hear about this. So please join me, Rob.
Thank you. I can't start my camera because it's blocked by the staff here, but happy to start that if you can.
Yes, I will stop sharing and then hand it over to you.
Thank you.
All right, thanks.
Welcome, everybody. Hello, my name is Rob Cameron, Technical Director over here at Roblox, and a Technical Director, not the Technical Director. Today, I'm going to talk to you about our journey of using Nomad that we've done over the last few years, and talk about a little bit about how Roblox uses Nomad on a day-to-day basis to keep kids happy and keep them playing Roblox and all their games. So a little bit about myself first. My name is Rob Cameron, Technical Director here of Infrastructure at Roblox. I love Linux. It's been one of my passions in my career my whole life, using containers, Golang, and then sometimes I get a little fun to play cello. I really hate outages, gluten, and misconfigurations of things, and love to keep everything automated and working together. I've been doing this for a little bit over 20 years, authored 6 books, a couple patents, and love writing a lot of code along the way. And a picture of me over there in the upper right with Lisa Namfi, who does all of the Kubernetes meetups in the Bay Area, and Eric Hahn, the original Kubernetes product manager. Sorry, I didn't update my picture for the initial part for the webinar here. I've been a little bit busy, so hence grown the beard from that. So before we get started, I wanted to do a brief overview of Roblox and what that is. Myself, I joined in December 2017, and when I first heard about it, I'm like, what's a Roblox? Like, I'm Rob, I love eating lox, but I had never heard of it because we don't have any kids. But as I started asking people out there, like, hey, what's this Roblox? What is it doing? I got a lot more info, and I wanted to share that with you as I've learned it more myself from working here. So Roblox is a massively multiplayer and online game creation system. It allows people from all over the world to play together in this very special way where we can route you together so that way you have an equidistant latency or just a great overall experience no matter where you're at in the world. So if you're in the US, you could play with your friends, or if they're all over the world, you can play with them and get a very similar experience. We have over 100 million monthly active users that play on the platform. And as they play together, that counts as somebody who plays at least one game, but I guarantee you that most people come back for many more games to play each month. Our game catalog consists of over 22 million games. And again, we probably have, I would say, a good top 1,000. But what I love is there's a good distribution of play across games. So it's not like 1 or 2 games that kind of dominate all of the player base. We have games anywhere from working in a pizza place. I love to play this with my nieces and nephews. I get to work up front, take the orders, they make the pizzas, they deliver it. It seems kind of simple, but it is simple and it is fun. And most importantly, all of the games and content we have are all created by our developers. These developers are external to Roblox, and anybody can go ahead and create a game, monetize it, and be able to share that with the world. You could do it right now, but I hope you wait for the rest of the webinar so that way you can enjoy Nomad Day before you start creating Roblox games. So when I first started, what lured me over here is being able to migrate our game servers over to Linux. And to kind of simplify what a game system looks like is you typically have game servers where you have lots of them. That's where the games are run. Obviously, it's why they're called game servers. And then we have the platform, which is kind of everything else. That's web, purchasing, sales, all of those different things and elements. So the first goal here that we wanted to do is move away from Windows and move over to Linux. Now, it's not that Windows is particularly bad, and it's very common actually for game companies to use Windows, especially on the server side. While iOS or Android kind of dominate the gaming market, most of the great development tools either come on Windows or case in iOS, maybe Xcode, things like that. But it's very common to see that. The thing is we're not particularly using Windows or its capabilities, so it just kind of makes sense to migrate over to Linux to get some operational benefits as well as the lower cost. So by being able to migrate, we're able to save at least $5 million a year instantly by moving that over, so which is a huge win. The other parts that we wanted to look at is be able to migrate over to 64-bit for our game services. This gives us more memory to be able to use and create more features. And then again, most importantly, larger game instances. The goal is as games change and the market changes, you have games like Battle Royale out there. This is 100 players playing against each other, and we want to be able to scale that. Someday, maybe we can even scale up to 1,000 or more players. So you could create your own World of Warcraft type style MMORPG right on top of Roblox. And we were looking at this, and to start the project, we wanted to ship our services within containers. I think nowadays that would be your minimum that you'd want to look at, and maybe even look at other things like OpenFaaS or functions as a service type solutions. But again, starting with containers, I think is a good win. When I was brought on board, I was given a 24-month time period to be able to do this migration, as well as bring the rest of the organization up to speed and train them. Sounds great. So as part of that, I'm like, hey, if we could do this on the game servers, could we use this kind of a Trojan horse to uplift the rest of the organization and move into our services to be containerized? So as part of that plan, we're like, hey, we have 2 years. Let's take a look at all these various options. By moving over to containers, we could go ahead and reduce our legacy tools that are costly to maintain or maybe perhaps difficult. I appreciate these legacy tools as they're the reason I'm here talking to you today, so I don't want to say that they're bad or anything like that. It's just over time, sometimes it's great to start fresh. The other ideas here is if we move to containers and an orchestrated system, we could also increase our server workload density. By being able to orchestrate our services, instead of having to do it with our existing systems, we may be able to have three times more services per server, which would then have less servers overall, which would then reduce costs, which is great, and then also make operations much simpler. And we can continue to move off of Windows, which again is providing less value for us as we're doing it. And then importantly, as we're doing this, we have to think about how we can re-educate the entire company to be able to use and move over to Linux containers. Before, I wanted to talk a little bit about the Roblox Global Hybrid Cloud, which sounds like a really good tongue twister. But the idea being is that we want to provide the best possible services for our players for the lowest possible cost, so that way you can pass that money back onto the developers of our platform. So when we think about this, the most important part is where can we position our infrastructure? Now, a lot of organizations default to using cloud. Roblox has been around for 14 years, and so we started kind of before the cloud trend. The other part is we want to control our destiny by having low-cost infrastructure, again, as I mentioned, to pass that back onto the developers, and really, in the end, give us the most agility for the business. So we want to build our points of presence, or our POPs, as close to players as possible, giving us high-density, low-latency compute. We can also do other things like edge network termination by peering with other internet service providers, by connecting to other networks, and then doing load balancing termination to speed up connectivity for our players. Majority of our services are run on bare metal. However, we do use strategic use of cloud compute with AWS, GCP, Azure, and other providers. So that way we can be, no matter where the players are, as close to them as possible with the best possible options. And to connect everything together, we have an amazing global backbone, which I always tell the backbone engineers, it's a real LAN-like experience, meaning I have low latency, low jitter across anywhere I connect. And this, again, minimizes player latency, which maximizes player experience. As I mentioned, we're distributed all over the world. We have over 20 locations or points of presence, mostly in North America, Europe, and Southeast Asia, but it will expand to meet the needs for any of our players. We also have regional data centers that were distributed across the world, so that way we're able to, again, provide services for those POPs within every location. What, again, I mentioned when you're doing matchmaking, we also take latency and distance for our various POPs into account, and so that makes it really interesting. And in fact, matchmaking was one of the parts that was one of the most interesting for me, is being able to do that without having to have regions or be able to break players up so they have to make decisions. How do you tell a 9-year-old where they need to play? They don't care. They just want to play, and we want to help them get there. Now, when you're looking at running containers, we could run that on individual hosts. We could do that with individual, like Ansible to deploy stuff or Chef. But really the key for containers is orchestration. Being able to place containers, migrate them if a host fails, and then also provide additional services such as config management, network connectivity, or storage. So if you're thinking about this, you definitely want to look into an orchestrator. So when we went through this evaluation, we thought about what should we use? Let's not limit ourselves to any sort of particular choices or options. I have a previous experience before this decision with Docker Swarm, Kubernetes, DCOS, some custom orchestrators, and a little bit of Nomad. We also talked about, should we write an orchestrator? Part of our game management system, it actually is an orchestrator in how we manage game launches. Is that something we could extend or use? As we're looking at doing this, is this something that's isolated to the game servers? Again, no, we don't want to do that. We want to use one system across both game servers and our platform. And most importantly, we were thinking, would we be able to, do we need Windows support? Could we migrate right over to Linux? Is that something that's easy to do? I think we all have that dream where we can drag and drop containers, drag and drop services, but perhaps that's something that we may not be able to do as rapidly. And when you're talking about this decision, you have to bring up and have that conversation. How do you not choose Kubernetes? Why not Kubernetes? It's the market leader. It's what everybody talks about. I think even my mom emails me sometimes and asks, hey, what's that Kubernetes all about? Now, for us, we went through those decisions. And for me, I'm talking here at Nomad Day, so obviously I'm talking about Nomad, and we didn't obviously choose Kubernetes. The one thing I always joke about is I wish we chose Kubernetes, so that way I wouldn't have to answer that question every time. But we'll talk a little bit about why we chose not to go with Kubernetes for our solution here. We chose a Hashi stack because it's operational simplicity. Each one of the services in the Hashi stack, Consul, Nomad, and Vault, which we'll discuss further, each one of them runs with or without a container. Easy to operate as a single binary. That single binary is the server. It's the client. It's your client that you would use locally to launch jobs or interact with the services. So it makes it very simple to distribute, understand, and update. It also does support that multi-platform workload support. Again, unfortunately, we can't move so quickly where we can just jump right over from Windows into Linux. So Nomad does support Windows. It supports running Windows containers through Docker. It also supports running other workloads inside of Windows. And so that was something that was very attractive to us. And also, Consul and Vault can be used independently outside of Nomad and can be plugged into those other systems without worry. A non-HashiCorp solution we used here, which was Portworx, for providing reliable storage, because we wanted to use stateless and stateful jobs, and we wanted something that would be very simple to use, operate, and manage. Now, I'll say something crazy, that all of this, and all that I'm going to discuss, is managed by a core team of 4 amazing people. These folks come from background experience of doing containers and orchestration, all the way to folks like my buddy Vernon, who's come in with very little experience in the space, primarily a Windows expert, and is able to go ahead and operate and deploy and upgrade things. And what's amazing is Vernon leads the charge for being able to upgrade our POPs, does it by himself, and also has trained other people to be able to help him. And to me, this is a huge win. I don't want something that's going to take a year or 2 years of effort to be able to get through. I want something that people can go ahead and jump into and utilize and upgrade and maintain. We're all doing this together as a team, and I definitely can't just do it by myself. And so I love and appreciate all their support. Now, for using Consul, our primary use case was looking at service discovery overall. This is not a particular surprise, as that's the core function of what Consul does. But the benefit is that we could operate and use this alone. So if the event that we want to use something else inside of Nomad, like Kubernetes in the future, we always want to have those options. Or we want to not go to orchestration or do our own thing, we can do all of that directly by using Consul directly. It gives us unified service discovery between Windows and Linux and other operating systems. We don't have to then rely on static configuration to find our service endpoints. A great example of this, an amazing engineer, Jan, in the earlier days of using Consul, had migrated our static services over for our caching tier, and then put that over into Consul. By doing so, it reduced our downtime and allowed us to find and auto-discover the services, which was great. And you can use DNS by default to simply interact with service discovery, or of course, if you have more complex logic you need, you can just use HTTP endpoints, which is what Jan did in his case. It's pretty amazing. From a Consul key value perspective, we use that for storing all of our Terraform state, as we use Terraform as much as possible. It's a great tool to organize and do configuration as code, and for bringing a little bit of sanity back in for change control. We also use it for Vault backend to store Vault data, any sort of configuration data that we can load and generate configuration templates with either Consul template or within Nomad. We use both. And then also semaphore locking, so you can do leader elections and other capabilities inside of Consul. And one of my favorite features that isn't really talked about is network tomography, where latency is calculated between all of the various nodes in Consul. And so that way you can make an intelligent decision about where to service traffic, or even just understand latency between services, which is great. Now, for Vault, the secret management system and more, of course, effectively, we use this to manage secrets across all our platform. It's a simple way to be able to distribute, update, and have a centralized place to use that. I think, though, that's selling Vault short. That's one of the base capabilities. The other capabilities we rely on today, and we're going to expand in the future, is using PKI or public key infrastructure to be able to spin up our own CAs to have isolated backends for all of our different POPs. So this way, in the event that there was an issue in a POP, we could collapse a POP, regenerate the CA, and move on with our lives and get that. And also, by integrating with Nomad, we can do certificate rotation based on TTL. Very awesome and simplistic way to manage TLS at scale. We do SSH signing, so that way we don't have to have passwords to do or any other on-box authentication. We can just simply use Vault, sign our keys. Vault audits the key signing, go ahead and access, and then the keys will automatically expire via TTL. Very simple. And what I love is also doing the database password rotation. So instead of interacting with static passwords and managing that, we can simply rotate the passwords, have those automatically configured via Nomad, and boom, we never have to worry about it. It's pretty amazing. I love it. And of course, the big point of today, talking about Nomad itself. So for Nomad, we do mostly use it for Linux containers because that was the goal for using and dealing with the game servers. However, we're now coming up with plans and using to actually do Windows clients. An amazing developer on our side, Dustin was able to take and understand how our Windows applications were deployed, as he's mostly a Windows expert. It's okay, we still love him. And he took that information without any Golang experience or really no Nomad experience. He wrote a task driver inside of Nomad to run our applications on Windows without any changes to the code. This is a huge win. We have over 200 components that we may need to port over. And instead of waiting years to do it, Dustin was able to take charge, be able to configure that driver, and now we're able to schedule our tasks, giving us that additional compression for our services. This is going to save us thousands and thousands of dollars per day on being able to reduce the number of servers we need to run. And I appreciate Dustin's work. The majority of our tasks that we run on top of Nomad are HTTP, REST, gRPC type of services, or really just stateful stuff that you can scale up or scale down. Processing jobs, right, running batch or periodic jobs to periodically do things. And in fact, we back up Consul or some of our Consul instances just using periodic jobs that go ahead, do the backup, store it in a remote location, and move on with their day. If there's issues, we get alerts. It's great. From a stateful perspective, we actually do something very crazy, which we'll talk about next, is running the Hashi stack itself, Nomad, Consul, and Vault, on top of Nomad. Wow, it's pretty nuts. But all of that is backed with Portworx storage, as well as some of our observability stack, Prometheus, InfluxDB, Grafana. I think we couldn't decide, so we just chose to use them all, as well as some databases and artifact registries. I love this because I can launch an application, have my service or container come up and come down, and it's easy to operate and maintain. I mentioned that we're running the Hashi stack on top of the Hashi stack here. And so let me just give you a brief overview. We have regional data centers in each location. We go ahead and spin up a POP. This may take a few weeks depending on hardware shipment and rack and stacking. We'll have a private set of nodes where we run Nomad clients, which are connected to the regional data center. On top of that, we launch Nomad, Consul, and Vault, as well as other control plane services that will go ahead and be backed by Portworx. Once spun up, we're able to bring up all of our game servers that run Linux. They tie back into the Nomad clients. And once they register, they launch our game management software instantly. So if a game service operator needs to go in and take down the server or maintain it the way they would always do, they can do that. And as soon as they're done, it comes back up into the cluster. And we can also use Nomad to run other system jobs across all of the fleet to be able to configure and manage or deploy different services very seamlessly. Everything, again, is connected through our global backbone, and our global backbone allows us to have high-speed, low-latency connectivity with multi-terabit capacity all over the world. Now, I mentioned the migrating game server piece. So again, the goal here, we had 2 years, but due to the capabilities that we had and the excitement around it, we condensed that down to 10 months. It wasn't really fun at first, but again, we did get it done. We ended up deploying it and meeting our deadline by the exact date. We deployed 1 POP per day, anywhere from 250 nodes to 500 nodes with a very small team. After the 8 days, all of the things were launched and Linux was all of a good go. We added 11 more POPs over the next year, and we started just with a few hundred game servers per node, per site, and we ended up with over 1,000 game servers per site, each in its own virtual Nomad POP. And by managing the game service with Nomad, we're able to deploy and make everything very secure in how we operate everything, reduce the deployment time, which used to take hours and potentially could have issues, down to minutes. And then we have secure secret management and rotation. So if we need to rotate a secret, API keys, things like that, we can do very rapidly. We've now taken global deploys down to 8 minutes. And my kudos goes out to the orchestration team who was able to fix that here in the last few months to be able to optimize that to the sub 10-minute mark. It's pretty crazy. And we're saying global deploy, we're shipping over to 11,000 nodes over a gigabyte size container in that speed of time. This is a slide I've done this talk before, and I always like to talk about where we've come from. When we started this project, when I joined the company, 0 containers in production. Today, initially we had about 200,000 active containers. Today we're over 350,000. We started that initial 8-day launch with about 5,000 hosts, and today we're over 12,000 hosts. Our huge gains here is we had up to 2x performance per game server. We moved to 64-bit, providing additional capacity. 2x performance per game server has more instances, which then ultimately saves money by giving us free hardware. The biggest pain we had over the longest period of time, since we recycle so many containers, is we had a bug in how Linux handles kernel slab memory. This is something that impacts everybody using containers, and so the fix actually lands in kernel 5.3 or a later version of CentOS 7.6 if you go that route. The fix here is amazing, and it helps us because we recycle millions of containers per day, and over time we would just effectively have hosts sitting there doing nothing. This is a picture of me and another gentleman, Victor, in the company, and we actually got the first game launch to start, so I love to just throw that up there. It was a very exciting day. I had some tears of joy. And then the rest of the idea here is we want to move the rest of the platform as discussed. First goal is we can move things straight to Linux. A lot of our code base being C#, we can go ahead and recompile it and just put it into a Linux container and go on with our day, which is awesome. Unfortunately, given how many services, that's not always possible. Because of Dustin's work, we're able to use our own plugin driver to be within Nomad to run services. I love the Nomad plugin driver system because it moves us away from just thinking about containers. There's a great community around developing these. And I was really excited recently about the AWS firecracker VM system. This is a micro VM that can start in 45 milliseconds. Oh, I wish that was in Nomad. I was busy, I looked on the website, and boom, the community contributed back, and I just talk about it all the time. I can't wait to go use that and use it within our infrastructure. And that's what, again, one of those powers I love of Nomad is it's not just about containers, it's about other things that you can run. So lastly, we want to be able to scale our services very sanely as we're building and scaling things up. So auto scaling wasn't a feature that came in initially, but I was always worried about it because it just makes bad code run larger. We want to ensure we don't provide any more resources without correct usage and moving for that. But I think we're going to have some discussions today where this could become a better reality inside of Nomad. I'm really excited about that. So if you're interested and you want to know more, this is part of a talk that is part of our case study. So you can visit HashiCorp.com, look at their case studies and find Roblox, or just search Roblox HashiCorp. I'm sure you can find it, as well as these other discussions that I had with Portworx, Ubuntu Masters, where I talked with Canonical about our usage of Canonical's mass, talk about Container World, which was the initial talk about the deployment here. And if you're interested in these problem spaces, we're always hiring at Roblox and looking for people that want to challenge the status quo, change things, and effectively make players happy. Because at the end of the day, all that really matters is that kids can get in, push the button, play with their friends. The average 9-year-old may only play for 10 to 15 minutes per day. They don't have time to wait for the game to load or for issues to happen. They want to push the button and play and have a good time. And for me, that's what it's all about. So I appreciate everybody coming today and listening to my talk. I'm here at the end of my time, and I'll be around later for the roundtable discussion if anybody has any questions. So I just want to thank everybody for listening, and I hope you appreciate I appreciate you listening, and I hope to chat with you later if you have any questions. Thank you.
Thank you, Rob. That was amazing. So if there's any questions for Rob and about Roblox and their case study, please ask the questions in chat, either on YouTube Live. We're following that as well as Zoom, and we'll answer them later in the panel discussion. We're actually going to mix things up slightly, and I will be presenting about autoscaler first, and we will then switch to task dependencies. So with that, let me share my screen and then take it from there. There we go. Okay, so I will be giving a preview of something we are working on, which is autoscaling, and I'm sure a lot of you are excited about autoscaling. So my name is Eric Veld, and I'm a developer advocate at HashiCorp. I know everybody just wants to get to the demo and see how everything works, but To start off, I just want to quickly look at autoscaling and why do we want to autoscale workloads and what are some of the use cases. So some common use cases for autoscaling is when suddenly load in our environments change, and instead of having to adjust our jobs, change the count of a task group, resubmit the job, or worst case, having to commit it into Git, wait for the build pipeline to finish, and then it getting deployed. We would like our applications to scale dynamically, right? So if we get an unforeseen increase of traffic, say for instance, we launch a new product and it's super popular, and suddenly we get 10x traffic, we want our application to be able to automatically adjust to that workload. Other types of loads could be events such as Black Friday, where we know when we can expect these peak and idle times in load, right? Because we know for each of the regions, when people will wake up, when they'll try to buy everything available in any store. And we know that we want to scale up at those time points. And then once that region goes back to bed, we might want to scale down our workloads in that region and then scale up for the next time zone, for instance. Another reason could be where we're running different types of workloads in the same environment. Say, for instance, you're running some background batch jobs, some machine learning jobs, some big data jobs, and then our core applications. Well, during peak hours, when users are visiting our websites, we might want to focus all those resources on the core applications. And then, say, for instance, we might still want to run some of the big data workloads, only we want to reserve just a fragment of our resources for those jobs. And then in the evening, when the load starts to go down, we might want to allocate more resources for these big data jobs or these batch jobs that we want to run at those times. And normally it's an issue with noisy neighbors, where if suddenly these big data jobs take all our resources, our core applications are then not running appropriately anymore. And then finally, we might want to scale based on useful metrics, because in the end, what matters is the user experience that we deliver to our customers. And if we have a website and trying to buy an item is very, very slow and the website is not responsive, we might want to address that by scaling up, right? So this might not be just the load of an application, but the important metric that we want to scale on is actually latency, because that is the end result that the user actually notices. Now, there's a few types of auto scaling, and I'm going to mention 3 of them, and we're going to focus mainly on the first one today, right? So the first type of auto scaling is horizontal application auto scaling, where we actually horizontally increase the number of instances of our applications to handle the additional load, right? So if we translate that to Nomad, this would be the number of instances of a task group inside a job, right? Then another way to scale is actually vertically, where say, for instance, we're running a database or another application that is quite resource hungry, and we actually want to scale it up vertically, so give it more resources, both in requests and in limits. And then if it doesn't need those resources anymore, we might want to scale those down again. And then finally, there's also cluster autoscaling, where we actually scale up the number of nodes that our applications are running on, which we can then use to either scale up vertically or horizontally, right? So the focus of my talk today will be the horizontal scaling of applications. And this is actually a problem that many have already tried to solve. And I'd like to give a shout out to some of the community projects that exist that try to solve these problems. One of them is Scalat from Trivago. And then James Rosell was involved in quite a few of them. You might call him Mr. Autoscaler. So we have Replicator from Elsevier, and then Chemtrail for actually scaling up the clusters, and then Sherpa for scaling up the workloads. And then we have Under Armour Libra. So everything I will be showing from here on is work in progress. So there be dragons and things might change. So if you see syntax, it might be that over time these will change. First, I want to take a look at how does an autoscaler work. And it's basically a closed loop control system where we have our desired state and we have our current state. And then every time we measure if we are now in our desired state, and otherwise we have to adjust the inputs and then measure again. And if we translate that to Nomad, then it would look something like this, where we have the policy that goes in as the set point, and then we match that with the strategy, and then we try to adjust the number of nodes and then check again the inputs to see if the adjustments we made actually change the metrics. And then if it does, then we don't need to scale anymore. If it doesn't, we need to actually adjust the values again. You can actually provide metrics from Nomad itself by exposing the allocation metrics or the node metrics, and by exposing those as Prometheus metrics, for instance. But to get much more meaningful metrics, we recommend using external APM tools such as Prometheus, or maybe services such as Datadog to get those metrics. And the way the autoscaler is actually built is very pluggable. So it relies on a number of plugins. And this is actually very useful because every user has a slightly different use case in which cases they would like to scale, or the inputs that they have on which they want to act when scaling. And the way it actually works is these plugins, they have well-defined interfaces, and then the autoscaler agent actually calls those interfaces on those plugins to evaluate if any actions need to be taken. So if we take a look at the different types of plugins that are in the autoscaler, we have the strategy plugin, which basically compares the current state of the system with the desired state of the system, and then produces a set of actions that need to be taken in order to reach the desired state. Then we have the target plugins, which actually function as two parts of the control loop. So they function as actuators when they receive an action request from the autoscaler. And they also serve as sensors when the autoscaler wants to get information about the current state of the system. And then in order for us to make decisions on scaling, we have the APM plugins, which will grab or query information from an external system or from Nomad, and then provide that to the autoscaler. So how does this work? How do we actually configure Nomad to start using autoscaling? Excuse me. So the changes that we have to make to Nomad itself are actually very minimal, and you might actually already have these enabled. So we want to be sure that we are publishing allocation metrics, right? So we want to set that to true. We want to set node metrics to true. And then we want to have the format of our metrics to be Prometheus metrics, right? So we can actually create advanced queries to query these metrics. And then if we have that, we need to start the autoscaler. So the autoscaler has been implemented as a separate process. And in my demo in a minute, I will actually be running the autoscaler on top of Nomad. And later on, we will actually allow the autoscaler to also scale horizontally itself. And all that the autoscaler needs is it needs to know how to reach Nomad in order to call the scale endpoints. We need to specify where we can find these plugins. And right now, there's actually a few plugins that get bundled in here, which I'll show you in a second. And then we can define a strategy plugin and APM plugins. In this case, it's the most basic, where I'm trying to grab the information from Nomad itself. So I define the Nomad APM plugin, which uses the Nomad APM driver, and I point it to Nomad so we can actually get information from the system. And I'm defining the target value strategy, where we can compare the current state of a query with the value that we want it to be. So say, for instance, I have average CPU load, and I want that value to be average of 1 over my instances. Then the target value will actually compare the current value with my desired state, and then give us a factor of how to scale according to that. And adding different APM plugins is as simple as adding that to the autoscaler configuration. So if we would like to grab information from Prometheus, all we have to do is define another APM, and we can have multiple of these defined in one configuration file with the driver of Prometheus, and then point it at a Prometheus server that we can then query. So as I said before, there are right now a few plugins that are bundled together. We have the Prometheus APM plugin, and then the Nomad APM plugin, and the target value. But we will be adding on to these later ourselves, and we hope that the community will also start to contribute these values or these plugins as well. And then all we have to do is start the autoscaler with the run command and pass it that configuration that I showed before. And it will then pick up all the plugins that I have defined in there and start listening. Now that we are running the autoscaler, how do we then actually get our jobs to autoscale? So there is a new stanza block, which is the scaling stanza block, which allows us to specify scaling for our task groups. So per task group, you can actually specify if you want scaling enabled, and then define policies as which the autoscaler should react to. In this case, for instance, I wanted to react to the average CPU, and I want the average CPU to be 1 for my instances. And then what we can define is we can actually define a minimum and a maximum number of instances so that we can actually limit it and not go crazy in case we get some metrics and end up with 9999999 instances of our services. And another example of a policy might be where we query Prometheus and we get the number of sessions per instance that is up. And then we have the average of that. And we can, for instance, say that we want the average number of sessions per instance to be 20 or lower. So that's what this defines. I have my normal Prometheus query there, and then the target value. So now let's actually get to the good part and try and show this in action. So I already have Nomad running here and Consul running here. I'm assuming I will need to zoom in slightly for this to all be visible. So let me first go to the browser and show that I'm actually running Nomad right now. I have a web app running, and all the web app does is report its IP and port. And this web app, currently one instance, is being fronted by an HA proxy. So when we start scaling it up, we will actually load balance between these instances. And then besides HA proxy and my web application, I'm also running Prometheus and Grafana on Nomad right now. And that is so we can actually query Prometheus and then start scaling on that later. So if we take a look here, we can see that my application is actually running. So this is the response from the web app. And we can see the IP and the port that it's running on. And that should actually correspond with the address we have here. Then if we take a look at our metrics, we can actually see that right now there's no load going to our application because I'm not running any load test on it. And we just have one instance of the application, and it's all going to one instance of that application. So let's start throwing some actual requests at this, right? So let's do make load. And for a duration of 5 minutes, I'm actually sending 30 connections to the application, right? So we can see that we're starting to get some load on the web app, and all the requests are now pounding my one instance of web. Well, as long as web can handle that and performance is fine, we don't have any issues, but ideally we'd want to scale up in order to react to this. So let me stop this, all right? And let me actually show you how we're going to change our jobs to actually react to this. Waiting for WSL, always a joy. Okay, so let's grab that first example that I had in my slides and start scaling on the average CPU load. So we're going to grab the average CPU load from our Nomad metrics, and we want the load to be a maximum of 1 per instance, right? And if we take a look back at here, we can actually see that we're generating way more load than 1. So let's submit this new job. Right, so we're sending that job in, and let me, at the same time, start opening the logs for the autoscaler, which I'm not running yet. So let's actually, start running that. So I'm actually running the autoscaler on top of Nomad. And as you can see here, we're now deploying that. And it's now running. So let's grab the logs of the autoscaler so we can actually see it react to the information. Okay. So here we can actually see that it's creating a PM. It's not doing anything. It's not telling us about any scaling actions, right? So we're actually running our new version of the application. In the load, we don't have any load, and we have one instance. But if we now actually start generating the 30 connections again, we now see the connections ramp up, and we should actually start seeing the autoscaler start making decisions. So what we can actually see here is that the autoscaler actually wants to scale from 1 to 2 because the factor is 3.0, right? And it actually noticed that it was not high enough. So it actually wants to scale from 1 to 4, now actually 1 to 3, because that load's actually bouncing a little bit. We should now start seeing that different instances of the application are going to show up here. Waiting for the delay in Prometheus. Here we see 3 instances of our application, and we can see that we have an average of 10 connections per instance. And if we take a look at the web app, we actually see that it is scaling because load of each of these instances is actually above 100%. And then if we actually kill the load, we will actually see the autoscaler react to that. There we go. And we can now see that it's trying to scale from 8 to 1 because there's no load anymore. So this is a pretty abrupt stoppage of the application right now. So no, the autoscaler actually sends a stop signal to the applications. So applications can actually gracefully handle the shutdown of the sessions and stop handling traffic. But later on, you'll be able to tune the actual grace periods and how fast it should scale up and scale down and how long it should wait for each of these. So that's a very basic way of scaling up. But if we want to do something more fancy, like the Prometheus query that we had before, where we're actually taking a look at the number of sessions and then spreading those out over our instances, all we have to do is define Prometheus as a source and then create a new query. And then in this case, we want the number of connections to be 20. So if we make web Prometheus, we've now submitted our new job, right? And we can see that there is now a source Prometheus policy registered. And then if we actually start generating load again, we will actually see that it's slowly starting to scale up. And this time it'll scale up way less dramatically than it did before. So right now it's actually trying to scale up to 2. Because the metrics we're trying to scale on is way less fragile than CPU load. So right now, the average number of connections is 30, and we should see that even out to about 20 as soon as all the new instances start coming up. So we can see here now that we're starting to spread the number of connections between our applications. And as soon as the load goes away, it'll then scale down again. All right, so if I take this away, we will actually see that Nomad has already scaled it down immediately. And this also works for extreme workloads. So if I do make extreme load and I'm trying to send 100 connections to it, it will scale up way faster because it actually determines the factor that it needs to scale up with. So as we can see, we've now scaled to 5. And if I move zoom out of the way, we can actually see that we are being load balanced over our different instances of our application to handle that load. Okay. Back to this. So with that, thank you. That was my presentation. We are going to move on to Jasmine, who's going to show us task dependencies. So Jasmine, if you are around.
Hi there. Yep.
Hi. Here. Are you ready to go?
Yes. And I'm going to make sure I zoom in my terminal so everyone can see it. Give me 1 sec.
Okay.
Hi, everyone.
Okay. Just let me know when you want to take control of the screen, then I'll stop sharing.
Okay. Am I sharing?
Yes, you are.
Wonderful.
Good luck.
Although there was some comment in the live chat, Eric, if we want to, people couldn't really see your terminal. If you want, or should I just go ahead?
You mean the terminal was too small, or?
It seems so. And the browser was really small.
Okay. I will record the demo again and then share that with everybody so they can actually watch a scaled up version then.
Sounds good.
Okay.
Okay, I'll go ahead then. Hi, everybody. My name's Jasmine DeHillig. I'm a software engineer that works at HashiCorp. And my latest project I've been working on is task dependencies for Nomad. So there is a little bit of lag with screen sharing and Zoom, but I think we'll manage. As Rob discussed before, there are a number of HashiCorp products. Vault, Terraform, Consul are ones that people are most familiar with, especially if you're coming from a Kubernetes scheduler platform. But we're going to be focusing on Nomad. Of course, this is Nomad Virtual Day, which is really about run and running your applications, which I think has a lot to do with runtime control. So before we get into that, I'll just go over, if you're unfamiliar, a little bit with the Nomad ontology. There's the concept of a Nomad job, and actually this slide is a little bit out of order. So a job is what you will generally use to describe your application, and it can be composed of a number of task groups, which are those four composed of tasks. And the task is the actual like workload, the executable that you'll be running. And the reason why there are task groups is so that way you can co-locate certain tasks onto the same client node. And you can also have like multiple instances of a task group. So a group of tasks that are co-located onto a node is, when it's actually deployed, it's called an allocation. So these keywords will come up. And so that's where the allocation kind of is. The allocation is the instance of part of a job, specifically a task group running on a node. So going back to what is Nomad all about, you are able to orchestrate your workloads, you're able to deploy things to a cluster. And sometimes you want to have a little bit of control over that. For example, you may want to run one task before another. This may be initialization, some sort of setup before your application runs. And again, this is all co-located on the same node in the same task group. You may want to set up some logging before your batch workload starts running. And so I did a bit of research in the community and figured out that the general use cases that people were asking for was initialization, which could include downloading secrets. One specific example I saw was converting a Vault secret PEM to a Java key store, starting a VPN proxy after the main application is ready, or starting a logging sidecar before your batch workload. Other use cases are cleanup, such as like flushing a database before shutdown, and then workflows and continuous delivery. So a lot of people wanted like really specific directed workflows for like batch jobs to be able to do that kind of like data processing pipeline stuff, which that's the experience I have prior to this. So I totally get that. And of course, continuous delivery. So when I was going through doing this research, a majority I found were really asking for a limited amount of task dependency use cases. So specifically initialization before the main app starts, and then cleanup. So thus introduced task lifecycle, which will be released with the Nomad 011 release, which introduces pre-start and post-start hooks for initialization. Long-term, it will also have post-stop hooks for cleanup. And it also introduces this new sidecar functionality, which works for both batch and service jobs. But specifically for batch jobs, it will allow you to run a long-lived task within a batch job task group. So a special task within a batch job. So batch job tasks are ephemeral. They run and then they complete, and they'll only get restarted if they finish, if they fail. So if they run to completion successfully, they won't get restarted. So the sidecar allows you to run a long-lived task in a batch job, and it'll live for the duration of an allocation. And then in a later release, we're also going to introduce automatic integration with the Consul service stanza. So that way, that'll allow you to use health checks for sidecar tasks. And the demo. So quickly going to switch over here. Oh, and I'll need another browser. Okay. Well, I'll run this first. So what I have here, let's just look at it so we can see. Cluster configuration file. Oh, is this big enough? Somebody please let me know if my font is big enough. And then I have a cockroach database cluster. And this will download a binary, run with the raw exec driver. And then
someone said it could be one tad bigger.
A tad bigger. Thank you so much. Come on, terminal, work with me. Tad bigger. I'm gonna think that that's good for now.
Yes, all good.
Okay, sweet, thank you. Okay, so we have this cockroach DB cluster and it's got 3 nodes. So node 1, and they're all basically the same, or they're all exactly the same. They run in raw exec driver, which just runs the binary with this command. Fun stuff, fun stuff. And so let's do it. So we're gonna start the Nomad cluster in dev mode, which just allows us to run, so the -dev allows us to run a server and a client all on the same thing. And so it's running. Okay. And now we're gonna run the cluster. Okay, and so let's watch Nomad, and this may be weird because the font is so big. Yeah, it kind of shows, it's confusing. Okay, we're gonna do it short. So this little flag is my best friend. It allows me to see everything. Oh, okay, well, we kind of missed all the action, but it was pending. If you noticed when I had it really big in the full text mode, but in the short mode, it's already gotten to running. So if we go to okay, so this is correct right now. It's 404 page not found, and maybe I can make it a lot bigger for people. And I'm going to keep going much, much faster, but we need to do some cluster initialization to get it to work. So I swear this will come out to make sense. So you could look at the logs. Successfully initialized, great. Now let's reload. So it's going to show us lots of stuff in really, really big font. So this is working. But it required us to do this manual initialization thing. And when you have automated deployments and just like generally infrastructure as code, you don't want to be doing a lot of manual things because it's error prone. If you don't document, like you have to run this initialization line, somebody who on another team tries to deploy the database doesn't know, and then it's broken. So let's shut this down. And Yep. Fine. Okay, so I'm just shutting down the cluster to clear out the cache, just so I have a fresh thing. So now what we're gonna look at is how I use the lifecycle stanza to introduce ordering. So let's get rid of this. Give us a little bit more room. Okay, there we go. We don't need that cluster information. It's Nomad cluster information. It's not as important. So, okay, sorry, just following the chat. So what I did here, it's kind of backwards because post-stop hook is not implemented yet, which we'll get to in a sec. What I did here was I actually made the initialization to be like the main application task. And then I made the nodes, the cluster itself, be a pre-start with the sidecar is true. So why did I do sidecar is true? Well, I wanted to run init to completion, but not have it restart over and over again. So I turned it into a batch job instead of a service job, which allows things to be ephemeral. So this is like pretty hacky, but that's why I'm going to show you that it doesn't have to be so hacky, but it will demonstrate like what a pre-start hook is and what a sidecar hook is. So I made all the nodes run first. So the cluster starts up. Then once the cluster is ready, it will run the init script. And how do I keep the cluster up? Well, I introduced these two hacky tasks to make one of the batch job tasks live forever. So that way it will keep along for the demo and there's a little bit of delay. But basically the nodes, the cockroach database cluster will start up and then there will be initialization. So let's do this. CR. This is also why I introduced a task that just delays. So it gives me time to type in keys. So these are running and they're pre-starts and they're sidecars. So they're gonna live as long as the allocation runs. And then I introduced a little delay that's also a pre-start. So it'll just kind of like 20 seconds, give me time to talk through what's happening here. And then what we're gonna see happen really quickly is that this is gonna start, or it's gonna be, this is the main applications are gonna start, and init is gonna start running and then complete really quickly. And I didn't have to do anything, but this should work. So it's a limited form of ordering. Basically that comes from like the hooks kind of like pattern, if you're familiar with like hooks from other applications like Rails. And it was sort of based off of like run levels. So this is really hacky. And let me see how much I have on time. So I'm just going to kind of go through really quickly what the code looks like. How did we implement this? So I guess one of the reasons why I talked about allocations versus tasks, and the zoom is like right in the middle. Oh wait, okay, there we go. Because it also corresponds to like what the code looks like. So every allocation, which corresponds to, again, let's look at the job. So every group of tasks corresponds to an allocation, which is actually the thing that's deployed to the client node. And then the allocation will be responsible for running each task, which looks like the alloc runner in the code, which is this like giant file of things that manages it. And the task runner, which actually runs the application. So the way that this primarily works is through Go channels and contexts. So I introduced this task hook coordinator struct that basically for every like group or allocation or task group, it keeps track of like the main task and what are all the pre-start sidecar and ephemeral tasks are. And there's slightly different behavior for the sidecar versus an ephemeral task. So like a pre-start hook that's ephemeral has to run to, oh no, the editor does not work at all on YouTube. Is it too small?
Yeah, could you bump the font up a little bit? Thanks.
Okay, good thing I already have grandma eyes. Da, da, da. Let's go to like 30. And also, I think we'll try 30, apply it. Is that better? I don't hear anything. I'm gonna keep talking.
Yeah, looks good. Go ahead.
Okay, great. Okay, so there are these two files that are pretty important. Alloc runner, which manages the actual running of the alloc, and that one keeps track of all the task runners, which run the tasks. So main, and then this is a big task runner run method. It's like way up here. So this is like super crucial, and I swear I'm gonna wrap this up really quickly. So the alloc runner manages all the task runners. And somewhere in there, we have a task hook coordinator, which basically the overall idea of it is that it uses Go channels and contexts to keep track of when should this task be started. And so it just blocks a task from being run until all the conditions are met, which is defined here, start condition for task. You could see that where it's blocking is in the run method right here. So it just waits until it receives a signal from this channel, and then it proceeds and actually does the main stuff. And I guess I could take questions at the end. So how do we add, and I guess I could go back to the task hook coordinator. How do we add how do we add more hooks basically? So it's going to look something like up. Let's see the changes. So I'm just adding a bunch of structs to keep track of, and there should be post start sidecar as well, but I was kind of crunched for time. And then we'll have another one of these right here, keeping track of that, and also have to update over here. So in the alloc runner, there's like a big, where'd you go? It's like a big for loop, like a long-lived Go thread that kind of just like watches the state of all the tasks and then updates the state in the alloc runner. So the alloc runner knows like everything that's happening. And this is where we update the task hook coordinator to manage that. So the task hook coordinator knows, okay, when should I send the signal to the other task to start? So we add another one of these. And there's probably going to be a little bit too much parsing for me. There's a lot in the like parse task and other bits of validation that won't show up here in this demo. They will show up in the branch or in the Lifecycle branch upcoming soon. So I'll go back to my presentation. So that's kind of what that, oh, and then here, actually, just to wrap that up, this is what it would look like. Go back. So it would look like this with post-op. It would be a lot simpler. It would be still a service job. And the init task would be post-start, not a sidecar. So that way everything just like makes sense. You run all of these as service job tasks, which means that they're going to run forever, or at least until they die or fail. And so what this will do is it'll start the main application and then quickly run this ephemeral post-start task. So that's what that's going to look like. Now, going back to the presentation, so I talked before about the use cases, how most people wanted initialization and cleanup and basically a limited amount of task dependencies. But there were still some requests for complicated or complex workflows and also continuous delivery. And that will be addressed not with the task lifecycle hook, but through upcoming ecosystem integrations. Workflows, which effectively require directed acyclic graphs, will be addressed with an upcoming Airflow integration with Nomad. So you'll be able to run Airflow on Nomad and also have that coordinate complex batch workflows, or even use that for continuous delivery for service jobs if you want. But specifically for continuous delivery, we're also implementing a Spinnaker integration, which I won't get into that, what all of that is. That's another demo entirely. So thank you. I guess I'll answer questions at the end of the presentation or end of the demo virtual day. Thanks, everyone.
So the next section will actually be a discussion and where we will also answer the questions, and we will have some internal discussion as well. Some of the speakers on the panels you might have already seen from the previous talks, but let me introduce the additional ones. So first of all, we have Andy James, a senior solutions engineer at HashiCorp, who works a lot with Nomad. We have James Rosell, Nomad engineer or Mr. Autoscaling. We have Charles Zephyr, SRE manager orchestration at Roblox. So that will be nice to answer a lot of the Roblox questions that we have gotten. Then we have Michael Schurter, who is also a Nomad engineer at HashiCorp. And then Rob, Jasmine, and myself have already spoken, and we will also answer any questions that we might have. So first of all, we had a lot of questions on the Roblox talk. So maybe we should start off with some of those.
Yeah, shoot them on over here. What do we got?
Yes, let's start off. So first of all, a question that I'm wondering about is, what do you like so much about Nomad? I know you've chosen it above some other schedules, but what is it personally that you really love in Nomad?
I mean, for myself, it's easy to use, easy for people to get started, and easy to explain. But even when you're done explaining it, there's so many more capabilities that you can use and how you can utilize it. So I love that, because using these services can be very daunting. And an example, like some job specs for other services or other systems can be very complicated, and how you use them. And again, they can do a lot, but it can be very complicated to explain it. In Nomad, you can go over the basic job spec, I think, within like a half an hour to get people started. But even from there, you can expand what you need to do. I think one of the biggest jobs we run inside of Nomad is maybe like 8 or 9 different services running in different groups side by side, or different pods, and then they interact together. And this is a Prometheus stack that I run. So we just started again with very basic one container or one service statelessly, and then now can be able to scale up to do something like that. So I like that, and it makes it accessible for other folks who haven't had experience with other orchestrators, just to get started right away. We primarily use the HCL language, which is the same language you use in Terraform to do all of our job configuration. It works really well for us. We also do use use Terraform to deploy Nomad jobs. So we do Terraform templating on top of Nomad templating to be able to give all of that flexibility for deploying jobs, which is really nice.
Okay. Yeah, we often hear that the low barrier of entry is very useful to the
Yes.
users. So you've been running Nomad for a while now, and I'm sure you've had some challenges. What has been your biggest challenge with Nomad, either Rob or Charles, whoever of you would like to answer that?
I'll let Charles take it for first, and I'll be happy to chime in as well.
Sure. So I would actually say a lot of our biggest challenges have been kind of political versus other challenges. So for instance, Michael Aldrich asks, was there any organizational pushback from not choosing the market leader of Kubernetes? That answer is yes. There's a lot of pushback. A lot of the stuff when Rob chose Nomad wasn't actually in Kubernetes. So this was a while ago. And the support for some of the specific edge cases that we needed was actually already in Nomad that wasn't in Kubernetes. The main thing being we require, we're a very Windows heavy shop. So we needed a strong Windows support, and Nomad already had that. Somebody else asked another question like, sorry, I'm just going through this, and because I saw there's a few questions in here. Something about, are you not using Docker in Windows? The answer is no, we're not. And that's why we're building our own driver, because Nomad has that flexibility. That specific team is not kind of prepared to go with, they're not really prepared to go to a Docker workflow. We've had some internal difficulties explaining things to them. They're getting it, but it's taking some time. And we've realized we can just utilize Nomad to a greater extent from our end to help fit it into their workflow, which is really kind of super helpful.
And I also want to say too, is like I always joke, and so that picture I had with Lisa and Eric, who are huge Kubernetes nerds, like, hey, why not Kubernetes? And so they sometimes call or text me like, hey, why did you choose Kubernetes yet? Just to troll me, and it's kind of funny. Well, at least it was after a while. But honestly, again, we do get that pushback. But what we're kind of seeing over the long run is it's just Nomad is working for us about making operational more easily to operate. The APIs are easy to work with. We're actually writing an overlay interface API we call for like Roblox cloud services on top of Nomad's API to be able to manage and deploy tasks ourselves. And I wanted to address, there's a question here about like an outage that happened after a case study. So with Nomad, with HashiStack, I would say we've had 4 major outages over 2 years. All of those were self-inflicted around like how we did some operational tasks, specifically with Vault or Vault sealing. The worst one that I had that made me sad was we had configured Vault to be like round robin DNS, and what happened is one of the Vault instances sealed, and over a long period of time, jobs effectively started failing because they thought Vault was sealed. So this was a misconfiguration on my side, and the worst part about it was on my birthday. Once we figured that out, we just switched over our Vault DNS record to use active.vault inside of Consul, and we fixed that issue. So that was my biggest problem. We did run into one substantial Nomad bug that did impact us, and this bug was in 092, where it wouldn't necessarily deregister a Consul service correctly. And so this impacted services like Trafic or Traffic, the load balancer that's used to integrate with Consul, and other services that integrated with Consul. So we're a little bit too bullish on upgrading, and that kind of caused the issue and got stuck with it. Eventually, the patch did come out, and then it has fixed that issue. But I would say that has been the biggest challenge. We also had some weird network outage another time where the Nomad servers ended up crashing due to a known panic condition. When that happened, people freaked out, jumped in to restart Nomad, but actually nothing went down when we lost the Nomad servers, which was really nice. Overall, February hasn't been necessarily the best for uptime as having outages, but as of, I would say, the last HashiCorp outage that we'd had would be maybe like late last October, knock on wood, again, due to some Vault stuff. One of the things we do internally, though, is we do a lot of chaos testing where we just basically try to destroy services and see the outcome so that way we can understand it. And that's led by Team Damien and Chris. And we really appreciate their work to kind of challenge us and to make sure things are stable. And that's been really good. And Charles is the one who, and his team is the one who kind of runs through all those. And we've done pretty well as far as those issues.
Yeah, and I just want to call out, we do those pretty regularly, and we actually monitor everything. And to kind of expand on that first question that got asked about the outage, we have actually learned a lot. There is, especially if you have any network instability, it's worth the few days to spend time tuning all the services to work around it, because they do have nice configurations in all of them. That's both all of them, Nomad, Consul, and Vault, to work around kind of sporadic network issues. Nomad specifically has some configuration tuning where you can say, hey, if the servers can't reach the clients for some period of time, just hang out, like just don't worry about it, give it some time. And that specific option has helped us a lot, because just sometimes we have some network issues. We have a large network, those things happen. So it's good to spend some time tuning around those problems.
And I think too, from like a Nomad client perspective, all the servers are sub like 5 milliseconds latency between each other. The clients can be anywhere from 5 or less milliseconds up to 250 to around 300 milliseconds away that we have distributed. So what I love about it is we could just plop Nomad clients as part of any cluster anywhere almost and get it to work. And again, tuning those configurations options makes it really flexible and easy. So we could put a virtual data center as one of the, so you have regions and data centers. We could put a data center within a region, but anywhere we need to place it to run specific jobs. It makes it super flexible and actually like works really well from that perspective.
Okay. Let's switch it up with some questions about the auto scaling, and I think I'm going to bug James for a second with those. So first of all, people are wondering if it will always be a separate process or not.
Yeah, so the plan is to keep it as a separate process. It doesn't mean that you won't be able to run it on Nomad like was demoed. There'll be some small kind of interlinkage between Nomad and the autoscaler for things like getting the scaling policies. And if you choose to use metrics from the Nomad server, but because of some design choices, such as kind of the load that autoscalers can go through, and the fact that we wanted to be able to iterate on the autoscaler quickly and not have any dependency problems that we might inflict on Nomad, it will always be an external application.
Okay, and an autoscaler follow-up. There was the interesting question asked, what happens if autoscaling is going on and you're resubmitting a job with a count? What is the desired result in that situation?
So yeah, so in the moment, that would not be a great situation. Going forward, there'll be a couple of changes to Nomad and how it handles the count effectively, so that when you submit your job, you don't have to do kind of a read back and update your job spec and then resubmit it. So that will be handled for you, so you won't have to get into any of those problems.
Okay, and I was wondering, Rob or Charles, like, is autoscaling one of the features you're looking forward to with the future releases of Nomad?
We've only been asked for that forever, and I would say definitely. And so I had a little bit of a tear, and actually was really excited to meet both of you auto-scaling experts, because we follow your work here on GitHub and have tested it. So I'm really excited to see that. The biggest thing for me with auto-scaling, and I've used it in other products, specifically DCOS, I did a lot of work with it, is people tend to use it as this magic tool to solve scaling issues for their application. And that's the whole point, right? But your application has to be ready to handle that and deal with that at scale for starting up and shutting down. And so that's what I've seen the biggest disasters with auto scaling is people will go ahead and say, oh, well, I don't have to worry about scaling my app or scaling the CPU per container. I can just have it figure it out, and you hit some sort of weird scaling issue. So what I love about the approach here, and Charles and I were slacking back and forth, is that the tier rolled down my cheek. It's like, I love the plugin model here where we could invent anything what we want with it. We have our own custom metrics pipeline. We can do all these plugins. Like, so excited about that part, because I just hate when you have auto scaling that can be very dumb and be based upon just CPU, because CPU may not be telling the whole story. And so if you can plug into all these metrics pipelines, that to me is the great part. Because normally I see CPU as being the focal point, and that I think tends to run into issues. But I'm excited for it. If you could just ship me that demo and that code after the thing, I'd love to see it.
Yeah, we'll package it up as soon as we do the release of the initial version. I will package up the demo with that, so you will actually be able to run everything locally as well, everything I showed.
Awesome.
Yeah, and that's something that we're excited from the ecosystem team, is having external people be able to contribute or come up and fix people to scale it into maybe if they have unique requirements, and that's going to be really interesting to see move forward.
A question for Jasmine. I was wondering, besides init containers, what other use cases do you see for the task dependencies features and the hooks?
Post-stop cleaning, as I discussed. I think a lot of it really is also the sidecar functionality for having a logging sidecar for your batch workflows. Seems pretty useful.
Maybe a question for you, Michael. Is the Connect integration actually going to leverage this new functionality?
Oh, that's a great question. We don't have that in the works today, but it would make sense to kind of port it over, because a lot of things that we can kind of hack around in Nomad today, task dependencies are going to make a lot more straightforward to implement. Yeah. So we'll probably take advantage of that in the future, but right now today, there's no work in progress.
Okay. Another question for you, Rob and Charles. What if you could request any other feature than the tier rolling auto scaling, what would it be?
Actually, the task dependency is one that I wasn't fully aware of it, and I'm actually super excited about it because that's something that's been requested internally and is really important for a lot of our workloads. So what we do now is we just kind of let stuff live in flux. So a good example would be we run Grafana, and it has a Postgres database, and they all run in Nomad, and we just basically let the Grafana UI fail until the database comes up successfully. And we just set some loose limits on the front ends themselves. And now with task dependency, that's going to be perfect for us. This is a perfect use case for doing things like that.
Go ahead. Sorry.
No, you go ahead.
I was going to say, one that Charles and I often talk about is node penalization. So if you run into a situation where you have a task that's trying to start and it's for some reason can't, being able to penalize that node for that task, so that way it could potentially move to another node. And our specific use case here is with the kernel slab issue. So basically, after X number of containers are started, no more containers can start until the node is effectively rebooted. This has been solved again with kernel patches, but we can run into a situation where a Docker container can't start, and Nomad will consistently try to do it. So what we'll do is we'll get an alert, or somebody will notify us, we drain the node, and then the task will move on. But something like that, I think, would be really useful to penalize nodes as they fail tasks.
Yeah, that's really good feedback, because we have the rescheduling block, as well as the driver health checks are kind of meant to handle this sort of use case. But I think it's pretty clear that a little bit like there are a lot of use cases you can hack around, that task dependencies will hopefully formalize and make a lot cleaner. I think there's still some work that we could do there to make those separate systems work a lot better for the situation you're describing.
Yep, and the way we've kind of come to detect it is we just capture all the logs from Nomad, and then we'll see that the allocation fails to start for a reason. And another example could be like Portworx has an issue, and so it's not trying to do it on that node, and it can't talk to it or something. So, but we just capture the logs and then do alerting and monitoring based upon that. But yeah, again, like we've talked with other engineering leads and stuff around Nomad, and our technical account manager Carlos has been amazing around us, and so we're confident those things will get worked out. But that's my annoyance of the day, at least.
Okay, and Andy, is this like a pattern that you see at many customers as well? the way they are basically doing what they would like to do with task dependencies, but solving it by basically flapping? Or
yeah, I've seen some of that. Yeah, I would say yes. That's currently what people are doing. So I think test dependencies is going to be very exciting for a lot of the customers.
Rob and Charles, a question for you again. You're running Windows workloads. How have you experienced the Windows support by Nomad so far?
So with the Windows side, we're just starting to roll this part out. But when we initially were testing it, I tested exec, raw exec, and then Docker containers on Windows, and wrote do everything with Chef, and wrote some Chef cookbooks to deploy on that, which was kind of fun. With the Windows stuff, our idea here is our services are running inside of IIS, and so instead of having to migrate the services over, Dustin on our team, he wrote the IIS driver inside of Golang for Nomad and has been testing that. We ran into some issues with like some stat collection, and there were some bugs around it. And I don't want to say it incorrectly, but we're working with our technical account manager on it. And I believe they're fixed in 0.11, so we're excited about that. But what's pretty interesting about it is we just take our existing artifact, which is effectively a zip file of DLLs and binary from Artifactory, use the artifact stanza, which is super flexible in Nomad, use that to deploy the code to the box, and then use our custom shim to be able to plug it into IIS and get it started. So with zero code changes for that. That seems to be the better direction for us, because again, we have like hundreds of components, which are effectively like microservices, for lack of a better term, when they were made. And by being able to do this, we don't have to go to each team or find an owner to fix it. We can just deploy code as is without any code changes, which is really nice for us. That's been going well overall, and we're looking at starting to roll that out in our test environments, I would say here, maybe beginning in Q2. And that's going to give us probably a 3 or 4 to 1 density, where we're having like hundreds of Windows machines to set up a test environment. And now we can just slimline those down and then just simplify the deployment process. So the end user, they deploy their code as is, and instead of just doing the old API, we flip it over to the new API, which is Nomad, to deploy it, which is really exciting. And what I love about it too is, so on my desktop battle station, which you can't all see here, Linux, Mac, Windows, I have a Nomad 8-node Pi cluster sitting over here. So I tend to work with everything. So I don't want to discriminate against one OS or the other, and I want it to work equally. And so for internally, that did win a lot of value, because there are folks who love Windows, and hey, there's nothing wrong with that. It's all good, right? I'm a Linux nerd. That's just my life and my career path. But we want to treat each of those things individually. And I'm excited for it, because again, we all have the dream of having those, clear-cut rollover or deployments or migrations, but that's never the case, right? And so this gives us a lot of leverage around it. And we've so I'm excited to see that come to fruition. And it's really, to me, that's the whole point of Nomad, is having that flexible driver plugin system, flexible OS support, and in the end, we win as the customer, which is awesome.
Is there any chance of that IIS task driver being open source? Because I've heard other community members wanting something like that.
Absolutely, yeah. Absolutely. Go ahead, Charles.
Yeah, I'll actually say this. We are talking to our internal people of like, how do we open source this? Because Roblox has like random open source stuff. It's a bit of a process internally. I actually think everyone who hears this and gets kind of hyped up about it, I think this is actually a great chance that while we're not releasing it today, open source, like we're going to figure out if we can, but I actually think this is a great chance for everyone to go look at how to write a plugin and see how to do it yourself. It's not hard. The whole entire plugin is not very big. The like POC that we have is like, I think it's less than 1,000 lines of code total. It's basically just to give you all an idea. I think it's just a wraparound SC to call the right IIS commands. I actually don't know all the details on it. Someone from my team is working with Dustin to take care of it. But we do, my personal opinion is I would love to open source it, but it's going to be not dependent on me, unfortunately. We got to talk to people and be like, yeah, we don't want to open source this. And then it's kind of an internal process to go through.
Okay, very excited about that. I was wondering as well about the IIS task driver. will it, or does it support things such as pulling in IIS applications as an artifact? Would Connect integration work? Am I adding a lot of feature requests now, or?
I'm actually going to say, Michael, maybe you can answer this one, because it's my understanding that if you have a Nomad, that all Nomad task drivers support most of the stanzas. So if you support service stanza, you should be able to just use Connect.
Yeah. So there's a couple tricky things that we're working on right now to help out with this effort. Number one is we don't have Connect support on Windows at all right now. Part of the problem with that is we only support Envoy for the sidecar proxy. Envoy is work in progress on Windows. It seems like it's getting close. We're monitoring that very closely. That should happen any day now, so that'll help out a lot. We're also looking to, we still don't have a good story around host networking for our Connect integration, where you don't want to use Linux network namespaces. You just want all the features of Connect without having to use network namespaces. We're going to enable that. And then Connect native as well. We're going to make sure to enable people who want to go that next step and integrate the Connect integration directly into their app, can go that direction. So for the IIS integration, I'm thinking that the host networking and Envoy on Windows are the biggest blockers today for that. But hopefully that's not going to be true for much longer.
My funny story about Consul Connect integration with Nomad is when it came out, I was, oh my gosh, I'm so excited. Roll the upgrade in my lab here, which is all pies. It doesn't work. I'm furious. I'm like, what's happening? I'm troubleshooting it. Long story short, everything worked. There's just no Envoy version for ARM64. And so it just couldn't launch it. And I'm like, oh my gosh, I'm an idiot. And so then I tried to build it for a while and said, oh, hopefully somebody else will figure it out. But it was pretty funny, fun weekend that time.
Oh yeah, this is the way that we integrated Connect is definitely new territory for us, as far as kind of blessing a Docker image in Nomad directly, as far as the way that we execute envoys through this Docker image. Now, it's all customizable, configurable, you can hack around it yourself, that sort of thing. But that is definitely kind of breaking new ground for us. And it's something that we hope to kind of refine and make better in the future. As it's probably clear to everyone listening right now, we're kind of really focusing on expanding our ecosystem offering. There's definitely lots of work going on in Nomad Core, and that's not going to stop, but we're really getting a lot of feedback from people that, especially people considering Kubernetes, are considering it not because Nomad is missing features as much, but Nomad is missing ecosystem a lot of times. And so we're really looking to enable more ecosystem development, as well as doing a lot more of that ourselves internally.
Speaking of ecosystem, James, you've been a member of the Nomad community and ecosystem for the longest time, and you've now finally joined us. What's it like transitioning from a community member to now actually working on the Nomad team and bringing your projects to fruition?
Initially, probably a lot of running around and celebrating. From the outside, you obviously get a sense of what's going on. But again, there can be frustrations, right? So I know you raise a PR or you raise an issue and you're like, oh, no one's read that in like 3 days. What are they doing? Whereas kind of being on the other side, it's manic, right? Like everyone's not manic in a bad way. Everyone's working on new features, trying to like fix bugs. And one of the more interesting things, one of the things I found great is just the open discussion, the technical dialogue that goes into just making small changes to make sure that it's right, to make sure that it's good from a UX perspective. And so it's great to kind of get that vision and that side of it. And also, I've been in the community for a bit. I tried to fix things. I've tried to create things. So now I'm excited to be able to do that on a full-time basis rather than from an 8 p.m. after the work basis. And it's really cool. It's great to see everything from a different perspective and hopefully be able to have some input into it.
So from the ecosystem perspective, What are some of the things that you'd like to say to other people that might want to contribute to the ecosystem? And I guess that's open to all the Nomad engineers.
So from my limited experience at the moment working at HashiCorp, so at least with the autoscaler, the way that it's been being architected is that it's very flexible. So if some of the things that we write don't match your use case, then we're hoping that the interfaces that are defined are simple enough that you can pick it up and start running with your own. As well, because it's an external application, hopefully we'll be able to kind of develop and move a bit quicker because we don't have the big dependency as well as worrying about what we're doing within Nomad Core. So our development cycle is separate, and so we can work to different kind of speeds as we require. You know, if we've got a small plugin and you know there's fixes, we should be able to kind of, we can take it at our own pace and hopefully, and just anyone that, you know, hasn't done open source, maybe it's their first contribution, just ask questions. Like, you know, that's the way I learned, is trying to get feedback and don't be worried. Like we're generally a friendly bunch, and we'll try and help out the best we can. And there's no wrong answer when you're trying to help us, and that's what that will be great to move forward with.
Yeah, I think too. Yeah, like James was saying, please don't hesitate, you know, to interact through issues, the mailing list, the Discuss forums, any way you can. I know that it's frustrating when, you know, the responses are slow or don't come or aren't what you were hoping to hear. But I think kind of what James was talking about earlier that he got to realize here recently joining the team, is that, you know, if we just type a 2-sentence response, that usually means a whole bunch of us got together and talked this over for, you know, a long time. And so we really try to put a lot of thought and care into our interactions as well. And so that means it takes some time. And I know we can't always prioritize things the way that everybody wants, but I promise we try, and that we really consider everything we get and really appreciate feedback.
Okay. I have another question for Roblox, and it's about scale. And I'm hoping you're okay with talking about that. And otherwise, just be as vague as you want. People are asking how large of clusters, regions, data centers you are running, like how many servers should people be thinking of? And mainly, have you run into any limits with scale with regards to Nomad?
It's a great question. So 2 parts, and I saw another question in the stream, so I'll address this too. From a server side, we're always running 5 servers as our target. The kind of interesting part, or part I love too, is that Nomad's clustering technology is the same as Consul. So if you understand one, you understand both, and they work exactly the same. The one big thing I would say that's a difference is that Nomad is a little bit typically behind Consul because, well, Consul's Consul, right? So it's always going to be ahead of itself. So as those things get imported, it's useful. We do scale sometimes up, like when we're migrating servers up to, like, say 10 instances, and then scale back down to 5, which has sometimes happened for both Consul and Nomad. The biggest challenge is, like, as you increase nodes, it can increase leader elections times. But again, we haven't particularly seen any issues from that. On the server side, a lot of our clusters are anywhere from, we have, let's say, 23-ish production clusters. We have anywhere between, 100 nodes or less to around up to 1,000 or 1,500 nodes in a specific cluster. In doing so, we have not seen any particular scaling issues for doing any of that. And we haven't seen any particular issues for the latency with the clients, which I had mentioned earlier. So it gives you some flexibility to push them around. Generally, I feel like Nomad's architecture is region and then data center, which is kind of matches to region and availability zone in AWS, for lack of a better example. And so we abuse that data center portion to do a lot of those things. As we're scaling up to a new POP design, which may exceed 1,500 nodes, we're looking again at Nomad scaling, and overall within the POPs, like, it's generally pretty stable and whatnot. We're not necessarily launching and starting and stopping a lot of tasks. But in our core data center, we do that very often and start and stop things and haven't seen any issues with it. The biggest challenges overall we've had is we've kind of abused Vault in ways which terrify people, where we've created too many certs or the certs weren't properly reaped or something like that. And so we've worked with HashiCorp on kind of resolving it. So Charles and another gentleman, Robert, from that team, they've cleaned all of this up. And ever since we've been able to go through that, we've had a lot of better situations around Vault and Consul. But on the Nomad side, it's just really simple, simple to easy to operate and scale. So we're looking at the max, we were thinking around up to 10,000 nodes in a cluster, but we may even just break it down, since managing Nomad is so easy, where we can break in the data center down to having Nomad regions within a data center to scale it up to keep it around like maybe 1,500 to 2,000 nodes. We just want to eliminate the blast radius so that way we don't have 10, 20,000 nodes and then one cluster goes down effectively. And honestly, switching things over is fairly easy, where we could take a Nomad client and pair it with a new Nomad server. We just go ahead and we'll redo the chef to get all of our certs and our keys and everything down on the nodes, and then just go ahead and point it over to the new servers, and it just migrates over, and then new tasks can run there, which makes it really easy. Charles, anything you want to add to that?
Yeah, I was going to say the Nomad servers themselves are basically idle all the time. Like, they don't really use much CPU or memory, even with thousands of jobs running in them. We also roll things pretty quickly. I've seen a lot of, just kind of answer this real quick, I've seen a lot of stuff on like, how do you deploy? Do you use Helm? No, we use Terraform. Terraform is basically like, you can just kind of DIY your own Helm. Our stuff is all really simple. It's like a couple lines of bash and a makefile, and we use Terraform templates. So we also do, since fixing some of the problems in deploys, we do deploys as aggressively as possible. So we're deploying to, out of those 23 clusters, probably 19 of them, rolling about 10,000 jobs, and it happens globally in about 5 or 6 minutes, depending on what we're doing.
And it's crazy to see, right? Because before it was this very scripted, huge pipeline to do deploys against the game servers. It just goes, updates, and we have a graph when we see dated versions of our game system. And it used to be this gradual burn down and gradual up. It's literally just one line, and it's deployed. The team that manages that, super excited. It's pretty incredible, to be honest.
So yeah, I actually really like that. I am really trying internally to get people to just be more aggressive with Nomad, actually, to say, hey, you can just keep deploying. It's okay. Like, if it fails, just keep trying. Like, it's not going to hurt anything. You're not going to cause any problems. That's why, like, some people may see the autoscaler and be like, well, if you're scaling up and down 10,000 jobs, are going to be any problems? And from my perspective, the answer is probably no. There haven't really been any hardware issues with Nomad. Like, the actual resource consumption has been really low, just across the board all the time. Yeah, it's been great. There's like some network spikes from time to time, but I don't think that's Nomad. I think that's just from like Raft doing huge commits, like when you deploy 10,000 jobs at once.
I think we have like one database migrator thing that gets spun up periodically that has hundreds of instances, and just spins up, works really well. Sometimes, again, we don't have capacity for it. We keep an eye on that, but it just smooth. The biggest challenges there we had was with some Vault stuff, but I mean, honestly, not Vault scaling, but just in particular how it was being used. But it's smooth and works really well. It's nice.
Okay, so right now, instead of auto scaling, obviously, you're managing that all manually, trying to figure out which applications should run at which times. Are you, like, how do you manage that right now, having to prioritize which jobs get run at which times?
Don't we use the periodic jobs for that type of thing?
We use the periodic jobs for some things, but for the most part, I would say outside of our very large clusters, all of our smaller clusters are internal facing, and we basically just tell people run whatever you want. I saw a question earlier about the enterprise stuff. We do use every single enterprise feature. So we use namespaces, we use quotas, we use the Sentinel. Like, my personal opinion is, just give people hardware and like just let them use it. So I actually don't want quotas. There's another team that wanted them on. I'm like, just turn them off. Like people will figure it out. If they fill up the cluster, we go talk to them and say, hey, maybe don't run 1,000 copies of your job. Maybe run 10. But just kind of giving people resources and letting them do whatever they want has proven to be mostly fine.
Well, what we've used internally too for prototyping is, so like if you download Docker, it has Kubernetes built in, you check a box and boom, you get it, right? So we built a thing called HashiDoc, which is a Hashi stack that runs inside of Docker, made by Dustin, the person working on the IIS driver when he was learning. And so we just bring it down. It's used as Docker Compose locally. We bring up an entire Nomad Vault console setup, and we can do it also clustered. And people can experiment when using it. Now, it's not necessarily fully featured because you know how Docker in Windows or Linux would work, but that's been helpful for folks. So when we talk about like integrating with traffic or other load balancing services, we can just run it all. Everyone can run it locally and expose it. And that's helped us out a lot to be able to have that full workflow. And as well as what Charles said, we just let people do stuff and let people make mistakes because that also helps them learn. And we don't want to be afraid for doing it. And in all of the abuse we've had, I think more than anything, people have abused Consul and Vault far worse than Nomad. And those have generally worked out pretty well from a scalability perspective. And I say generally, we've had issues with VMs not scaled enough to be able to handle load and stuff. But I think we're now running 4,000 plus services inside of Consul, you know, and then maybe a couple thousand nodes, which are like Windows nodes as well. They're outside of Nomad. So it makes it really easy to have those two pieces come together in a real hybrid environment.
Yeah. I will say something that has actually helped has been an internal kind of like pattern thing. Basically, where we say, hey, like if you're gonna run your Nomad job and you want to do the specific thing, here's kind of a copy paste block for a template. An example would be like people like to put a bunch of Redis servers in their stuff, and those are registered in Consul, and it's not obvious out of the box in Consul template how to string delimit something. So having some blocks like that to just kind of copy and paste. Another example would be, people have talked about this in the chat. I've seen a couple things about running stateful sets. The pattern that we currently use, so I think Nomad 011 is going to have some stuff to make this way easier, but the pattern that we currently use is with Portworx. We use Portworx and we use allocation ID to kind of allocate multiple individual volumes to each service, so that way they can float around and they'll still have the same persistent volume. And that works really well.
Have you, by any chance, played around with the host volume feature that was, I think, released in the previous release?
We are on 09.
Okay, so that would
Oops.
be a no. So
that would be a no.
In the next release then?
Not yet.
Okay.
Because
that might be interesting.
I've played with it around at home a bit, but and I don't, because I don't run Portworx because I can't afford that for myself. But it seemed to work pretty well, and very similar to a Mesos feature, I think, that I can't recall the name of.
But yeah, I think an interesting thing that people may not realize is that the variables, the HCL variables that Nomad exposes are available in most stanzas. So that's how we use the volume stanza to put the allocation index ID into that. Like it just templates out. It's not like an environment variable or anything. It's just that they're just available as variables in HCL. So you just stick it in there.
Yeah, like we'll run HA Prometheus or Nomad or Consul, and we just take that alloc ID, and then the volume is like 0, 1, 2, 3, 4, or whatever, and it does it automatically. It's really slick, to be honest. We do the same where in Consul, let's say we have a service Prometheus or Nomad or whatever, and we have like Nomad-server or whatever we call it, and then we can have individually addressable by also registering a service using the alloc ID. So then you have instance 0, 1, 2, 3, 4, so you can address it directly in case you needed to. So you have the flexibility for it, and it makes it really nice in the event you need that.
Andy, have you seen any other patterns when dealing with stateful applications that you might want to share?
That I might want to share. That's a good question. So I would say Probably not completely honestly for a lot of the, so a little background on who I am. I'm a solution engineer down in Tola area for everybody who's on the live stream. And honestly, a lot of the customers down here are very much stateless. It is actually not common to see stateful applications in Nomad for this particular customer base. That does not say that they don't exist. And I've seen the occasional databases and things that are being run stateful, but it's actually very commonly to see quick sort of like more like the app side. So the things you can spin up, spin down, throw away, build new. A lot of that is what I see a lot of Nomad customers down in this part of the country doing.
Okay. Rob and Charles, it looks like you've been very successful in moving the whole organization towards Linux and containers and schedulers. If somebody has been watching today and is excited about the things you have done, do you have any advice for them in how they can bring this to their managers or like make it successful in their organization?
So yeah, I'd love to take this one. So for me, when we initially started orchestration migration, talking with our CEO, I said, orchestration is a great way to destroy your company, jokingly. And my point being is that there's a lot of aspects you need to deal with it. You build pipeline, container builds, all of this. And so different companies have different ways to look at it. The ways that I've seen to not be successful is you're trying to solve everything at once or do this huge design, because then you're making the barrier of entry so large to get started, you can do it. So I have this simple phrase I like to say, it's double negative on purpose. You should make something so easy you cannot not do it. Because if it's so easy that it happens automatically, then people can do it. So what I mean with this is opening up Nomad for people to experiment, letting people fail with it, not having huge stringent requirements around what it takes to get started really helped us, because it allowed our users to experiment internally, to come up with design paradigms that we couldn't do ourselves or couldn't think about with our own imagination. And the organizations I've worked with that have kind of faltered with this, they come up with these huge standards, all these specs, all of these requirements, like thousands of pages of documentation to read, where somebody just wants to like have his application started. So I think the way we've been successful is opening up access, letting people experiment, let people break stuff. Again, this can be frustrating on our side, but just having people learn from it. And when you're building it, start small and find a specific use case. So a good use case, for example, in Nomad, you could just run it to do distributed batch jobs, right? That seems really simple to get started. You don't need a huge complex setup. You may not need Consul, you may not need Vault. And from there, you can build organizational experience to kind of expand on top of it. And what I see happening a lot of times with, like in particularly Kubernetes, and again, I'm not negative against Kubernetes, but this is the pattern. It's like, oh, we want to pick this distro and we need all these features. And then you put it out there and you're like, what have I just done? Like, how do I support? How do I onboard users? But if you grow users with our orchestration as you're doing it, it will be a bit painful and people will get upset because they're used to their application sitting on a single server that can do anything it wants. And so it may misbehave. Now you're forcing them to co-locate in a small slice or container with other things. So it could be painful, but I think it's worth it because the long-term agility you get from having containers, shipping that way, changing your organization to think differently is super valuable. We're lucky that our applications mostly can be ported over, but there's some companies I've talked to that are running like COBOL-based or Ada-based applications that are like super old, and there's that one old guy with the beard, well, not me, but somebody other old guy with the beard, kind of running and maintaining those apps. And how do you do it? And I just say, hey, it's just hard and it's okay. And you're gonna get through it by going through it slowly, getting people exposed to it, getting the momentum around it, and then eventually it'll happen. And I can tell you honestly, when I had early discussions around containerizing their game server, this doesn't work, it's not scalable, no one uses this, these types of attitudes. And again, this has changed, where now we're using that to empower to have dynamic configuration on our containers for limits and CPU things with our own applications. But we're able to do that. And that's our ultimate goal, is to take that custom orchestration we do with our game system and move it into Nomad. But we want to do it when people are ready. So in long story short here, let people experiment, let people fail. It's okay to scale up and build. Don't start with some huge lofty goal of this perfect environment. You're not going to get there right away. build with the organization and grow together with your users. And I can guarantee you through that type of mechanism, you can get there. And if your organization is super large, what you want to do is also have guide rails. So here's best practice Nomad job. Here's best practice your job spec. Best practice for monitoring. Because at the end of the day, application developers want to just ship code, which is the whole point of what they do in their major business objectives. So the easier you can make that, the better it is. Because most of the time, people don't want to fiddle and faddle with container settings and registries and all these different things. They just want it to work and ship code. So you as the operator or administrator of the orchestration side have to flip your perspective to think about how those people think or what they're trying to think to do and achieve. So I think that would be successful. And Charles, anything you wanted to add to that?
Yeah, I want to add specifically, this is specifically for HashiCorp products, is that they are some of the best products to implement one at a time. So like you don't need Consul, Vault, Terraform, Packer, Vagrant to run Nomad. You don't need all those things to run Vault. You don't need all those things to run Consul. Like it's implementing it one piece at a time, or rather introducing it one piece at a time is totally fine. And I think it's an interesting thing is you can introduce them all at once as well. Then users themselves don't have to also use all of them. If someone just wants to use Vault, if someone just wants to use Consul, if someone just wants to use Nomad, you can use just the one piece or all of them or any combination that you'd like. And we've had a lot of success on that front. For someone just asked, what's the best tool to start with? I would actually say Nomad and Vault. So if you don't have anything at all, Nomad is a great place to start with. If you don't have anything like Vault, Vault's a really great place to start with. And for both of these, they don't require Consul, but Consul gives you enough good things that throwing Consul into that mix really kind of gives you a lot. And operationally, they're all pretty easy to run. I think our configurations for Consul and Nomad are like 20 lines. We really don't touch many of the defaults. It basically just works. Vault actually I think is even less. It's like 8 lines. Vault is a really good place to get started because you get ACLs for Consul Nomad. If you're using AWS GCP, even if you're using Kubernetes, they have auth drivers just in them. So you can say, hey, look, we don't have a good way internally to get like tokens into these things. They just work. Someone asked, where's the AD integration? The answer is it's in Vault. You integrate Vault with AD, and then you can take that and integrate that into Nomad, which is how we do it. So then you get your kind of end-to-end security with all of your existing tools that integrate into all the things that you just stood up with very little configuration. None of this stuff is hard. I promise if you take a month or even a week or even a day in some cases, like the AWS thing, so easy to set up, you can do it in a day. And having these demos kind of up and running and just showing, hey, look, I did this. You can do it all in Terraform and you can give a make file and you can say, hey, if you run make, you can just have this locally on your workstation. Another thing would be somebody asked, how do I get started with open source stuff? How do I push that, sell that? We internally did it by running kind of Linux first technology alongside our Windows stuff. So we actually started with Elasticsearch, Memcache, and Redis. Running that stuff alongside Windows is really, I think it's important to have some open source tech and just say, hey, look, this is free and not like it doesn't cost money. Like it's just there. You can build it yourself. You can do whatever you want. I actually think you're probably going to get a suspension of kind of people won't believe you that it's free. And I think that's the hardest sell on open source technology is if nobody's ever used it, and that does happen, that is a thing that comes up. I know people will be watching this, so then they'll say, well, no, I don't believe anyone's ever used open source technology. And the answer is there's a lot of people who haven't. And it is a tough sell, but if you just keep saying like, look, this is out there, like you can just use it. And if we find a bug, like we can fix it ourselves. I think kind of pushing people into that, like, look, you have the power to do this yourself, is it's a big hurdle to get over. Once you get over it, it helps a lot.
Amazing answer. Thank you so much. Okay,
I actually have
go
a
ahead, Jessica.
follow-up. Eric, can I ask a question?
Yes, of course.
Really quick for Roblox. It's a follow-up question to something you said earlier, which is that you're still on Nomad 0945.
We're on 097.
On 7. Okay, great. So this in particular is relevant to me because I may have shipped a bug in 092 that caused some problems that was later fixed in 094. We won't talk about it, but the yes. At HashiCorp, we have a principle of prioritizing the practitioner, and upgrading, enabling practitioners to upgrade to the latest and greatest without any pain points, I think is really critical. So is there a way that we could improve that experience for you?
I don't know how much I can talk about what we talked about with HashiCorp directly. Someone from HashiCorp, Michael or Eric. But if you want to know our experience internally, so we do have enterprise, so we get that enterprise support. By the way, if anybody has a budget for it, it's totally worth it. You should get it, even if just the support if you don't use any of the features. We did a lot of pushback with HashiCorp internally, and we said, look, here is our workloads. You have to test these workloads. They have to work for us. And everyone on HashiCorp side was like, okay. And if you actually look at the Nomad GitHub, you can see that there's been a lot of work put into the end-to-end test suite. And I think if anybody has an interesting enough test case that isn't in there, like, you just go put it in there, or you can ask. You can put in a thing on GitHub. That's what I do from time to time, where I'm like, I don't know if I should ask this from like Roblox. I'll just go ask on like GitHub. But yeah, on our end, we're dealing with some infrastructure issues, which make it difficult for us to get test environments. And we're working around that on our end, but it is nice that HashiCorp is super dedicated to improving their testing when working with customers directly. And somebody asked, what's the best way to learn Nomad and get hands dirty? You can run it in one command. Just go download the binary, and it's nomad agent-dev. That's it. There's nothing else to it.
Same with Consul involved. And I do that all the time where I need to spot check something, test something, restore a backup, validate it. It's like test suite is locally there. So even beyond the HashiDoc stuff. And sorry for the noob joke with that part. I think one challenge we see too is that in point releases, you still can potentially add features. So we generally are waiting for like after like 0.4, hopefully that new features won't get added. Not that we don't want the features, but we want like stability of the features and bug fixes for it. So.
Makes sense.
Yep.
Yeah, so we're slightly over time, but it's no biggie. I would like to thank Rob and Charles for joining us so much. You've been amazing, and I've loved hearing all your stories. And yeah, I hope everybody had fun at this first edition of the Nomad Virtual Day, and hope to be having many more in the future.
Yeah, I'd love to come back. This panel discussion has been amazing. I love it.
Always welcome.
Thank you.
All right. So with that, let's close it off. Thank you, everybody. Any questions that were asked in the chat that we did not get to, we will actually send a follow-up email trying to answer as many as we can of those afterwards. So if your question did not get answered, don't worry. We'll try and get to those. So yes, thank you, everybody.
Take it easy, everyone.
Thank you.
Thanks, everybody. Have a great day.
You too.
Bye.